All right, welcome everyone. It's lovely to see you all for our regular OHDSI UK or OHDSI UK OMOP Interest Group meeting. I want to welcome Lucy Vickers, who has joined OHDSI UK as Chief Data Officer and is going to be co-chairing these sessions with me. Unfortunately, Geoff Hall has stepped back due to ill health, and I really want to wish him all the best in the new stage of his career and his life in general. Just to mention a couple of things before we start, we're going to be recording this meeting. If you have anything else, please raise your hand now. I also want to mention that we have now got the OHDSI UK 2026 meeting all arranged for the 18th of September with a training day on the previous day, 17th of September, both in Nottingham, and the registration is open. Hopefully Alex and the team can put a message in the chat so people can find the link very quickly. Also to mention, all the materials from OHDSI UK 2025 are available on the website, and maybe Alex, again, I'm going to ask you please to post a message on this in the chat. And finally, also to say all the previous OMOP Special Interest Group meetings have been recorded and are available in YouTube. And again, I'm sure Kath or Alex can write a message in the Teams chat so you can all access that easily. We have quite a packed agenda for today, but a lot of interesting bits of information and talks. Lucy, unless you have something to add, maybe you can take a minute to introduce yourself to the team in case somebody hasn't met you yet, and then we hand it over to Alex.
Okay, thanks so much, Danny, and it's great to be here. So I'm Lucy Vickers. I have joined OHDSI UK about 6-7 weeks ago as the new Chief Data Officer. I came from the Department of Health and Social Care, where I was the Chief Data Officer there, and it's great to be here. And I think I have met quite a few people on the way, but if I haven't met you yet, I hope I will, and I'm really looking forward to today. Thanks so much. Thanks, Danny.
Thank you, Lucy. All right. I'm sure everybody has seen the agenda already. We have Alex speaking about OHDSI UK 2026 for 10 minutes. Then we will have a few other colleagues talking about different topics, but I'm going to hand over to Alex first. You're on mute, Alex.
Yep, sorry. I hope you can all see that. So I don't plan to take 10 minutes, but I just want to give you a quick brief and a quick plug for the OHDSI UK meeting this year. So the meeting this year is being hosted by our colleagues from the University of Nottingham. So to give you a flavour of what we're planning, the meeting is on the 17th and 18th of September. So the 18th will be the symposium, the same as in the previous couple of years, if you've been to one of those. And on the 17th, for the first time, we're running a training day. And again, there's a full programme for the training day on the website, and Kath is going to share the link in the chat. So there's 3 parallel strands on the training day. So working with the OMOP CDM&R, ETL and federated analysis, and clinical phenotyping. And we have 4 invited speakers, Mukesh Kumar from A-Star in Singapore, Alexander Davidov from Thesaurus Health, Daniel Key from Great Ormond Street Hospital, and Dan Dedman from CPRD. So as well as the invited presentations, we'll have lightning talks, posters and software demos, which will be from the 54 abstracts that have been submitted for the meeting and that we're currently reviewing. So should be a great day. Please look at the link and see what, read about the information about the event. Happy to answer any questions you have, but please remember to register, and look forward to seeing many of you there. Thank you.
Thank you so much, Alex. Indeed, we hope to see many of you in Nottingham in September. Please register before you go on holidays when you forget. or we sell out as we have in the next 2 or 3 years, and then we end up with a very long waiting list. All right. I can see Onesimus is online. Hi, Onesimus. Good morning. Onesimus is going to be talking to us from Health Innovationists about linking data across multiple hospitals using OMOP, heart failure, proof of concept in the Eastern England SDE. Onesimus, if you're ready, if you can introduce yourself briefly, and then the floor is yours. We have around 20 minutes for your talk.
Hello, Danny, can you hear me?
Yes, very well.
Thank you. Good morning, everyone. I'm Onesimus. I'm a data manager at Health Innovation East, and I'll be going through the OMOP mapping of our heart failure data sets in the heart failure use case. So I will share my screen. Hopefully it should work. Just want to confirm, can everyone see this?
Yes.
Thank you.
Yes, Onesimus, very well.
Okay, great. Yeah, so this presentation will be describing the mapping process to map heart failure datasets to the OMOP CDM version 5.4. If you have any questions on the current structure, which links data across multiple hospitals, please, you can ask Magali. She's also on the call. So just an introduction into why we use the OMOP CDM. We use it to standardize medical data into a common format for collaborative research. There are many benefits to the OMOP mapping, including the ability to use a common suite of analytical tools from OHDSI, which enhances research capabilities, and the open source packages offered allow for continuous improvement to the model and the tools. So I'll introduce the Eastern England SDE. So this is a view of the architecture as of the time that the OMOP mapping was completed. So our architecture is hosted on AWS, and there is a data flow route from our trusted data sources to the project research environment. And so it consists of these main steps. So an SFTP upload from a trusted data source is provided to upload de-identified patient data to the data landing zone, or the DLC, here. And then after files are successfully validated, these can be automatically copied to the data integration platform. And so within here, an ETL pipeline can be deployed to propagate the data sets from the raw bucket through to the research bucket in this data integration platform. And then once it reaches the research bucket, this can await what we call a data sync process to be able to sync the data set to the project research environment for researchers to access. So our MVP pilot was the heart failure use case, which started over a year ago. And so this includes data featuring patients with heart failure, as primary diagnostic codes. And the aim of the project was to validate risk prediction tools to help identify high-risk patients. And so we had 3 different trusts that provided several data variables for events spanning a 10-year period prior to upload. And so these trusts were Cambridge University Hospitals, CUH, Milton Keynes University Hospitals, MKUH, and Norfolk and Norwich University Hospitals, NNUH. And so the SDE was tasked with providing the researchers not only with the source data sets, but with the OMOP versions. Hence, we had to consider a design process for the mapping. So the overall data model consisted of 6 tables for each trust. So demographics, admissions, diagnoses, tests, procedures, and medication administrations. And so I was able to draw some initial connections to identify key mapping relationships between key attributes and OMOP. So wherever you see a connection here is a potential mapping transformation, and the key attribute associated with the source table would determine the main concept or concept ID that is captured in the linked OMOP table. And so where you see a key attribute with an asterisk, this indicates that some of these codes could fall outside the initial domains that were linked to them, because it's possible for ICD-10 codes to not only fall within conditions, but they could also be observations or procedures. So we needed to implement a logic that factored that in. Go to the next slide. So this is an overview of a common ETL pipeline that is used in ISDE. So our ETLs are in the form of a state machine, which is used to execute a workflow of Lambda functions. And Lambda functions themselves are used to run Python code. So a Lambda function may be a Python script that defines some variables like memory and storage, and it's used to run some Python code, in this case to transform data. And the advantage of this is that you don't need to manage servers. So if you can see here, the main tasks as Lambda functions that are included in our standard ETL pipeline are a function to copy data from the raw to the intermediate bucket and from the intermediate to the research bucket. So we had to be able to integrate our OMOP transformations between these two steps within an intermediate bucket so that we can apply these transformations. So because it wasn't easy to simply just add a new Lambda function to perform all these transformations, we needed to distribute this work across various Lambda functions so that the ETL implementation is efficient. So this is just an overview of the process that I outlined. So the key factors of this process were the order and the mapping methodology. So the mapping could be divided simply into two stages. A first stage to map every source table to a single intermediate table where a key OMOP relationship has been identified, or in this case where you have clinical events with potentially various domains, mapping these to domain-specific intermediate tables, depending on the key attribute. And then these tables could then be staged as CSV files in an intermediate location, awaiting the second stage. And then the second stage would structure or restructure all these intermediate tables by either simply wrangling the data to output the final table or stacking various intermediate tables for each domain separately into their various OMOP equivalent tables. And it was important to establish dependencies, for example, ensuring that you are able to generate a patient key person ID dictionary from the demographics mapping. So it was key to map this table first, and then wherever you have an encounter key, map the admissions table second, so you can have a record of encounter keys and visit occurrence IDs to link clinical events. So this is an overview of the mapping of clinical events. Overall, what this aims to do is to map fields using local mapping tables to a domain agnostic STEM table, and then using some local mapping tables to perform what I call domain mapping. Map these records from the local STEM table to the equivalent OMOP domain. This would involve partitioning this STEM table into intermediate subsets by their domains, so using the domain ID that has been captured through the source code CSV to get their intermediate subset. And then this can be staged, as I referred to earlier, this can be staged in an intermediate location, awaiting a stacking process to just amalgamate intermediate tables for each domain separately into their final destinations. And so to develop these local mapping tables, I had to prepare this using Athena, essentially, taken advantage of the vocabularies you can download. So I downloaded the concept and concept relationship tables, and I was able to manipulate using R to develop a source code table for each vocabulary set present in the data. So a source code table for ICD-10 codes, OPCS4 codes, medication codes, etc., to be able to map those source records straight to their domains. Also, here shows a value CSV dictionary, a value table type concept table, which would allow the mapping of secondary attributes that may be relevant, like procedure lateralities or services, to a relevant concept ID. And then also the patient key and encounter key dictionary, which would have to be imported from the mapping process itself before it's imported into the mapping. So the idea was I would either import these tables into the mapping via what we call a lambda layer for the lambda function, or simply just programming it directly into the mapping scripts for the code to refer to. So our new ETL requirements were to respect these logical dependencies identified, enable concurrent OMOP table mappings where there are no dependencies, and execute mappings for each trust separately. And so the final design of the ETL workflow, if you can see, these are parallel branches where each branch separates the transformations for each trust. And within the branches, you have an arrangement of workflows where I have grouped the lambda functions into kind of different stages, depending on the dependencies and what is required to be mapped first. So overall, you can see here where you have a function circled in green is a mapping operation, and where you see function circled in dark blue is where you see a stacking operation to perform that final stacking of the tables. So this is actually a view of the CUH branch, and because they didn't have encounter keys, we didn't need a separate stage for mapping those encounter keys to visit occurrences to generate a visit occurrence dictionary. So the main operations for my Lambda functions were either a bulk file transfer to simply move files, a mapping process or a stacking process. And the larger, or the Lambda functions with larger memory assigned were the functions that performed stacking processes due to the size of the files. And so there were a few challenges with the design and implementation. So with the design, there was data missingness. So the OMOP CDM requires person IDs as it's person-centric, and dates to be able to map dates. So wherever these key fields were not present, that record was unmappable, resulting in data quality issues. Inconsistency of the entry of source codes. So it may be something simple like an ICD-10 code having a decimal point or not having. And so there were added pre-processing steps to mitigate that. And creating local mapping tables also had the issue of possible inaccuracy of and not a very representative concept ID. With implementation, there were various iterations due to larger source files causing Lambda functions to be prone to what we call the timeout error, where this exceeds the execution time. And so a lot of fine-tuning was involved to ensure that this error did not continue and the ETL can succeed. And so the conclusions that I've derived from this mapping overall to deliver this data set to the researchers is that Lambda functions are suboptimal for heavy OMOP mapping, although you can improve this with greater parallelization by adding more functions to maybe further partition the data. And a source data QA, a thorough one, is critical for a seamless ETL implementation to reduce the number of unnecessary iterations for the ETL pipeline. So that is it. If you have any other questions, there are some details here for our email website. Thank you.
Thank you, Asimos. See that sharing your email address. Any questions, anyone in the audience?
Can I be naughty and ask a quick question? You can just say, email us later, or you can think of a nasty question to ask us. This mapping, I love the way you're layering it. I love that you've really thought about this. That's great. How does it relate to the mappings that UCLH and CUH have done on their EPIC data? Or is that that's a question for another time, if you like? I mean, is there an easy answer?
No, sorry.
Okay, right.
Yeah.
Okay.
I mean, I
He's a
can
bad
take this
person
one
who
if
asked
you
the wrong
want,
question.
Jim.
Is that Mag?
Yes, it is me. Good morning. Yeah, so there are essentially two separate processes. So this was the preliminary work as a proof of concept on 3 sites. So although we did have existing collaboration with CUH, who had their own pipeline adapted from UCLH on EPIC data, it did not translate, obviously, directly to the Milton Keynes and NUH data sets. So we developed a separate pipeline for this particular heart failure focused OMOP mapping. What we're doing now, kind of in the expansion of it and the scale up, is that CUH have their EPIC to OMOP pipeline. And so they give us access to the OMOP database. And then separately, we're building a different OMOP pipeline at NUH and MKUH to be able to link those data sets together for further research studies.
Thank you.
Thank you.
And sorry if it was awkward. I didn't mean to be awkward.
It wasn't. Thank you for raising.
I thought it was a good question. Any other questions, anyone?
There's a question from Laura Kerr in the chat. Laura, did you want to say anything?
Yeah, hi everyone. I was really interested in how the ETL deals with concepts that don't belong in the assumed domain. I mean, the example I'm thinking of is where we have something we would normally map to value a string, and it's not an observation. It's potentially could result in data loss. And interested to know how these stem intermediate tables would deal with that. Could you give us a bit more detail, or should we talk offline?
Yeah, we could also talk offline. So, for example, wherever there's a code representing like a source concept, what I have is a source code table. So the source code table is basically a merger of a concept and concept relationship table. So essentially, it records the source code, its source concept, and then uses the concept relationship to determine the standard equivalent.
Right.
And then joining on the concept table again, you can actually get the domain ID of that standard concept. So that's essentially used to map the domain between that source record and the equivalent OMOP table. Yeah.
And I presume once you build information, if you could identify anything that's a value string, and that would give an indication of data loss before proceeding further.
Yeah.
Brilliant. Thank you. Thank you. That's really helpful.
Thank you, Nasimos. I think there was another hand up from Rachel. Do you want to speak up, Rachel? Rachel CP. Rachel, can you hear us?
We can't hear you, sorry.
She wrote her question in the chat, right? I think it says, apologies if I missed this, but what were the database management systems data models of the source data sets? I think that was in your slides actually.
Yeah, so in terms of the tables included, this was essentially the overall data model for each trust. So demographics, admissions, diagnoses, tests, procedures, and medication administration records. These were provided as just flat CSV files to the data landing zone. Just received tables.
I guess it's worth noting as well. So COH used Cerner as the APR system. MKUH used, sorry, other way around. COH used Epic, MKUH used Cerner, and NUH do not have an EPR system at the moment. What we did is we gave them a target data model. So it was basically up to the trust to map the existing local systems to our target model, and then we used that to build the OMOP on.
Thank you, guys. Any other questions from the signals? All right, Antonella, please come in.
Yeah, hi. Just curious about the dimension of these three data sets from a patient point of view, from a size point of view, or follow-up or something, just to understand how big this mapping was. Thank you.
Yep, so if I remember correctly, I think for CUH, the data represented, I think, about 200,000 patients. Magali, sorry, do you have any more information?
I think it was smaller than that. I can find you the official link because we have published it on the OHDSI UK gateway. So I'll put the link in the chat in a minute. But I think it was around 16,000 patients for both. Let me get this the right way around. I think both for CUH and MKUH, and then 9,000 patients for NNUH.
Okay, and how long did it take for you to map this data? Not to create the logic.
Right.
When you created the logic, how long did it take the actual transformation to happen?
Right, from start to finish, it will take between 15 and 30 minutes.
Okay, thank you. Good.
Okay, one last question, Roshan.
I'm Roshan. I'm working from University of Bristol, and we are thinking about whether we want to implement OMOP or not. So I was just wondering, is the mapping code open source? Something that we can look at?
Currently, it's not, but I might be able to point you to where I have published, I think, the logic behind it.
Okay, yeah, that would be helpful as well. Yeah.
Right. Okay. Thank you, Magali and Onesimus. That was very good to hear. I think we are ready to move on to the next presentation. Jim and Joe, I don't know if it's the both of you in a kind of duo or you're going to cover this.
I'm hoping that Joe is driving. Joe, are you driving?
Yes.
Are you showing the slides?
I'm
this is
happy to
because
drive.
Joe
and I
is
think Jim's gonna
the
start, yeah.
star here. And in the words of Roxette from 1995, if I'm correct, don't bore us, get to the chorus. So Joe, slides.
Just 1 second. I'm finding the. Hopefully you can see that.
Hooray. That's who we are and what we're about to talk about next. Brilliant. TVS STE, thanks to our partners across the region. So smaller population footprint than the East. However, on the plus side, we do have detailed data flowing into our environment from the majority of NHS organisations within the region. which is quite a lot, really. And we have 2 acute trusts no, 1 acute and 1 community and mental health who aren't fully signed up. We have 1 Epic Trust, which we don't have an ETL from their core data store as yet, because that turns out to be a little bit impossible. Our approach elsewhere has been, give us your data, all your data. I mean, not all the rows. We don't necessarily need all the rows from all your system right now. I'll come to the cache in a moment. But we want all of the relevant tables from your EPR. So what we do is we have a Microsoft runtime endpoint from our Azure that will sit in the environment for Milton Keynes, and we have a copy of their Cerner. We don't have it real time. Oxford, we have a real-time copy of the Cerner database. We don't need to do that for all the partners yet because we don't have the use cases for it. But Royal Berkshire, Great Western down in Swindon, Milton Keynes, these are all Cerner sites, Oracle Health now, which means that actually we figure this once for an Oracle Cerner installation. I know they're locally configurable, but they're not that configurable. Same goes for Epic. It's not that configurable, actually. And the core information model remains the same. So we pull all of the data. We've got the ambulance service. We've got the council, which is going to be very exciting. And we integrate what we do with FTP. So a big shout out to our friends from Palantir there, because actually that is, unless the FTP is suddenly stopped, and I don't see any sign of it, absolutely key in terms of future common representations of NHS data in the future. We do multimodal data, free text reports, hospital notes, clinical letters, who wrote that? Clinic letters, we call them. And the interesting thing about that is so much of it is free text or PDF or in some cases photograph. Next slide, please. I love the architecture diagram. We have a similar sort of, we don't really bring in data from untrusted sources to the first. I mean, we just don't. I mean, our data comes from our partners. We don't have research data sets that come in general. And we're not against it, but we just don't do that. In fact, we don't really do data sets. We do data flows, because of course, all of these operational clinical systems are being updated in real time. It doesn't mean we don't do cuts of extracts and snapshots for research purposes, but the warehouse runs. And we also look at supporting consented studies, which means that everything is identified in the warehouse in our bronze and silver. We de-identify when it comes to silver to gold. Gold exists in 3 different parts. We call the first Gold A. It's a data layer. Gold A is, here's the representation of the data as it comes out of Cerner, Infoflex, ARIA, our LIMS system, CRIS, all of the different stuff. Just keep it as close to that as you possibly can. Gold B is common data models, so FHIR, but OMOP. So we have the source data, and then we have, and this is where Joe's about to come in, not quite yet, we've got one more slide, Joe, you know, the OMOP version thereof. So we can revisit the mapping if we need to. We don't take a data set in general, and OMOP it. Of course, we'll take snapshots of, for example, it's quite useful when you're really working at the shallower data with the commissioning data sets. If you're going to do that, you might as well OMOP them year by year. That's going to be okay. But we really see this as more of an ongoing, which is why Antonella's question was bang on the money. It kind of isn't that important, although it is interesting how long it takes you to process a given data set. But those processing times become really important if you're looking at doing it at scale routinely to the routinely collected data. So, and then we have a TRE world, which is pretty much commodity, and it is as you'd expect. The key thing, though, is that you'll see the word catalog turns up twice. For the moment you get into anything that's for regulatory approval, we've said this, we've rehearsed it many times, you need the assurance, you need the mappings. If you haven't got the mappings, you can't really ask people to use the data, because you're just asking them to trust you and you're absolutely sure that it's fit for purpose. In general, we think that's more sort of open safely world where actually, you know, you've got a lot of assurance that comes out of the team that provides that service. It doesn't scale hugely well, although I'm sure Ben's working on that. What we've got is, here are the mappings. You can have the mappings, publish the mappings. So that's another thing that Joe has been focusing on. Last comment, Joe, can you show the cache, which is the next slide? Yeah, so this is what we've got, and for this audience, no, we haven't OMOP'd at all. No, goodness me, because that would take a lot of work. But we focused on some of the stuff that other people are OMOPing so that we get this national benefit. We want to be team players. Joe, over to you.
Thanks a lot for the introduction to the SDE there, Jim. And yeah, of course, I'll mention some of the rest of the team as well, because it's certainly not just me. So to get down, I think, to the specifics of the OMOP mapping and the tool, what we've been doing. So as Jim mentioned, we've got several trusts which have data flows established to TVS SDE at the moment. I think off the top of my head, we're up to about 7 acute trusts, and then other types of organisations, other trusts, and some non-NHS providers as well. But here's for the OMOP mapping currently. There's a summary here of what data flows we have established and actually mapped in OMOP. So we've got 6 acute trusts. We've mapped some standardized NHS reporting data called SUS, Secondary User Service, which is related and very similar to the HES data, but it's easier to get at with the regional governance we've got at the moment. And then for one of those trusts, which is currently OUH, we've also mapped 3 additional reporting data sets that are relevant to the cancer data. So cancer outcomes data set, SACT, which is essentially the chemotherapy data, RTDS, which is the radiotherapy data. And as well as that, so those 4 data sets there, SUS and the 3 cancer ones, are all NHS standardized reporting data sets. We've also additionally mapped some EPR data as well, also for OUH, Oxford University Hospitals Foundation Trust. So that's the raw EPR data. And for that, we've mapped medications and laboratory test data because that isn't available within the reporting data. So our kind of approach basically was, because we knew we wanted to build a multi-trust, multi-site mapping, we didn't want to necessarily go to the effort of remapping absolutely everything that might be already in a usable format in these standard reporting data sets that obviously a lot of people in the information teams and so on in the trusts put a lot of effort into producing. But it is all linked, so we've got the option of adding in additional data directly from EPR mappings where there's that high value use case, such as for the medications and laboratory test data. And we've also got the national data opt-out, or rather technically the list of patients who are not opted out coming in as part of the governance as well. So there was a figure mentioned in the slide before of around 4 million total patients in the TVS area. So between these trusts and sources, we've currently got some OMOP data released for 2.6 million. Obviously, there are some different subsets there because for OUH, we've got more OMOP data currently than the rest of the trusts, but that's a reasonable proportion of patients in TVS have at least some record in the current OMOP data set. So that's about the data. In terms of the tool that we've developed, and a team working with Oxford University Hospitals and also at Answer Digital Consulting based in Leeds have developed an OMOP mapping tool. We've published the code and the Docker image, which you can use to run the tool on GitHub. And as well as that, we've also published the transformation documentation that the tool actually generates. So we've tried to build in recording the lineage and provenance and generating documentation as far as possible from mappings where they're using standard and reusable bits of code, things like copying values from a source field to a target field in OMOP, or things like doing something with a date field. We've published all that transformation documentation. It's on the GitHub Pages link that you can see there. So one thing to note about the tool is that another of our aims is to basically include as much as possible of the ETL process all bundled within the tool, because we recognize that the precursor steps to what maybe sometimes the mapping is only considered as going to the OMOP concept IDs, and then there's a sort of previous bit of ETL to do with loading the source files or loading the raw data into a database before the mapping happens. But actually we're seeing the mapping as being the whole process from the raw files that we receive from the trust and the data flow connection that were mentioned in the previous slide, all the way to through the ETL stage of the data, all of the transformations, and then some standardization to output the OMOP data set. So the idea is that if you do happen to be based in another SDE or an NHS trust, which might have access to these reporting data sets, if you can supply your own data to use locally, you can download and run the tool on the files basically as you have them, and it should give you a valid OMOP data set based on those files. So here's some more details on the implementation. So as you can see, we've got the data coming in currently from our TVS data lake, which is based in Databricks. We've got EPR data and the national data opt-out. For some technical reasons, we're currently pulling in the reporting data set separately as some files. But then within the tool, we've got mapping based on SQL. It's actually implemented in C#. We're trying to make the mapping as declarative as possible. So it reuses code where it's common amongst different data sources. And in terms of the implementation detail of the ETL, we're using DuckDB as our database for the ETL database and transformation. We found that to be very practical. It's very fast, and also it's quite good at it's basically a sort of file store backed analytics database, so everything is self-contained within one file. So it's quite good for running the whole ETL process in some pipelines within restricted virtual machines, and then also being able to practically move the database around at the end once it's mapped. We found that to be quite practical, and it's also quite fast. I think, to preempt a question potentially about the performance and so on of the tool, I think the 2-point-something million patients we've got currently, it takes about half an hour to run the mapping on all of those sources that were mentioned before. So we're pretty pleased with DuckDB, and we previously were using some different database and have found this one to be much faster than that. So that was a good good improvement to switch to that, actually. So to get into some of the details of what the actual mapping code looks like in this tool, here's a little snippet of one of the mapping files. This one is for SUS APC, which is Secondary User Service Admitted Patient Care. So it's basically the inpatient HES data, so one of the key reporting data sets. And as you can see, just scanning the code there, it's basically mostly based on applying annotations to a class that's called OMOP Condition Occurrence, which has the sort of parent hierarchy of what the condition occurrence class should look like in the output, and then applying some annotations which tell the tool where the source columns are, where the source data is in the source input files, telling it declaratively what mappings it should apply, because many of these are reusable. Copy value, obviously that's entirely reusable. ICD-10, select a diagnosis code from an ICD-10 input, obviously that's also reusable and something to do with dates, and then puts the output into the standard OMOP columns. So because it's based on annotations, the tool can keep track of the provenance. So I mentioned the GitHub pages transformation documentation, and here's a small screenshot from that that you can see at the link that's included there. So for this mapping class, the same one on the previous slide, SUS APC, Admitted Patient Care, it generates a sort of diagram which has the source field names, NHS number, CDS activity date, primary diagnosis, and then the target location of where these get mapped in the OMOP schema. That's a pretty simple example, but if you have a look on the website, there's also ones where it's got multiple fields being mapped to one field in OMOP and some other things. And as you can see, it includes some standard documentation that's been added for the reusable mapping annotations. So it gives you a bit of detail about what the ICD lookup code there is actually doing to the data. So you might be wondering, why have we implemented a custom tool in C# and SQL and used annotations if in fact you can reuse a lot of the mapping code for many of the files? And the reason is it comes back to we want to have a tool that really includes absolutely all of the ETL process, including any transformations and exceptions. And there are definitely cases that we come across where we see that basically some custom code is needed for some cases. Often things like joins or aggregations, things like maximum and minimum values over dates, and sometimes over not just dates in the whole file, but over some kind of aggregation group based on some criteria. And when we have that, we definitely want to include all that logic in the tool as well. So if for some reason you can't use the reusable annotations, you can essentially override the class for a particular mapping file. And here's an example that might be a little bit small, but you can see in one of the cancer outcome reporting dataset mapping files, there's some custom SQL there that's got a bit of a coalesce function and some other things within it. And also when we do this, we essentially have a kind of thing that encourages adding some documentation manually alongside the custom mapping. So the tool obviously doesn't generate the documentation for these custom mappings itself, but they're all version controlled and managed in the same place, so that when the custom mapping is updated, the documentation should be as well. And then that's included in the exported documentation alongside the automatically generated diagrams. So you can see there's a bit of custom SQL and a bit of explanation of what that is doing there. And that's obviously intended to make it more reproducible. So you've got the full logic. And I think I would say that even if you look at the mappings overall, most mappings use the annotation. So most of them don't involve some custom SQL. But when you do get to things that involve a bit of custom code or SQL, it often might be a kind of quite high priority field, something to do with the dates of conditions and things that, often the things that are important can be the most irregular ones. So in terms of deployment, I mentioned a Docker image was published, and it's also within the GitHub repository link there. So within TVS SDE, we've got this deployed within the essentially the secure area within TVS SDE that we have for the processing of our patient data. And we've hooked it up to some Azure DevOps pipelines, and the screenshot on the side there you can see is what we can see in our Azure DevOps setup. So we've got all these different stages of the mapping that we can turn off or on depending on what we want to run. And this is also quite good for development, of course, because it means that when we push changes to the GitHub, we can go back into our DevOps in the secure side of our environment, rerun the mapping, and see what happens with the output. And something that I think has been quite good is that I have to say, Answer Digital and some others in the community have been quite helpful, making some tweaks to some of the OHDSI tooling and some other tools to basically support our process as we've uncovered things that might be useful. And I think one of those that I think it was James Cockayne at Answer Digital, who's really been leading on lots of the implementation of this project, has contributed something back to the OHDSI DQD project to just add a sort of console output for the DQD process so that you can actually see the DQD checks in the console log as well as the web page rendering, which is obviously really useful for running in a CI pipeline like Azure DevOps, because that kind of expects the console output to be where the validation is. So we have that there. Include as part of the Azure DevOps pipeline that runs after the tool runs. It also runs the DQD checks, so that as we're again pushing updates to the code, we're continuously getting that validation to see that we're still complying with those standards. I'll also mention OHDSI UK cohort discovery. This was really what got us started looking at OMOP within TVS SDE, was the feature that was part of the SDE network. HDRA UK, as probably many of you know, run this cohort discovery service, which allows researchers who pass a fairly lightweight validation to run self-service aggregate feasibility queries on OMOP datasets across several different organizations, and it gets them an aggregate figure of how many patients might be in a dataset that's suitable for some research they want to do. So you can see the link to the Health Data Gateway dataset there and the cohort discovery service. And we have deployed Bunny to connect our dataset to the cohort discovery service. And again, thanks to some people in the community for making a few tweaks to run Bunny with the DuckDB database, which again, we're finding very performant and seems to work quite well. I'll just very briefly touch on some work we've been doing recently on using AI to assist in the mapping process. Probably won't go into all the detail here, I think perhaps for another time, but for there's basically two broad areas where we've been able to use AI to help with our mapping. So I mentioned the laboratory and medication test data we're mapping from the EPR raw source system for OUH, and that data is locally coded, so it's not necessarily in the standard ontology or vocabulary for the medications and laboratory tests. It's basically stored as display names that are displayed in the Cerner EPR that we have in OUH. So to assist in mapping that to the Athena vocabs, we've been using semantic embeddings from an LLM and the RAG technique to produce essentially a big file of candidate mappings with a semantic similarity score, which essentially acts as the confidence. And that's allowed us to map thousands of medication laboratory test concepts very, very efficiently. And obviously, looking broader at the TVS region, we've got certainly more trusts than OUH, and there's 7 different trusts, at least 7 different acute trusts that potentially we might be able to get medications and laboratory test data from. So this sort of technique really seems quite promising in speeding up the mapping process, because obviously doing that manually in the Athena website would be very, very time consuming and labor intensive. And another interesting use of the AI that has also been successful is actually using a coding agent to do some metadata-driven mapping based on the NHS data dictionary, because the reporting data sets that we're using are well documented in the data dictionary. And so pointing some of the coding agents at that metadata documentation has also let us speed up the mapping quite a bit. So yeah, certainly there's a whole team behind this, and these are the main technical people involved, but I know that there's some others, including some on the call here, who've helped us out, so thanks very much. I want to give a massive shout out to James Cockayne and Kyan Amin at Ans Digital, who've been leading the technical implementation of this, and I think certainly we think they've done a great job. And on that note, if you are a researcher who has a reason to want to access OMOP data, then TVS SDE is open for applications. We have had one application for the OMOP dataset approved, and I'm aware there's some contracting being worked on, but we are open, and you can have a look on our website there and the inquiries link. And I think broadly we'd be keen to receive applications. And yeah, thanks for listening, and any questions?
I'd just like to add my own shout out to Danny and the team, because I mean, sure, one of the business imperatives was the HDR gateway, but actually, no offense to HDR UK, but we probably wouldn't have done all of this if it wasn't for Danny and his team. We probably just would have done the minimum and moved on. Whereas having Danny and the others explain some of the value, show us what can be done, and actually just be there. And if does the TVS SD have some embarrassing laundry? We haven't yet got our complete comprehensive framework agreement between the trust and the university, so that we can have a program rather than a project by project setup. That's almost there, but I think that's Danny and Co have been very patient actually during that. So big thanks to them.
Thank you guys, that was very impressive. I think it's worth mentioning, when I talk about OMOP to all the SDs and many other data stewards around the country, it's a bit frustrating to see that some people are losing their patience, saying, oh, we don't do this anymore because nobody's using the data, when actually one of the reasons we're not using the data is that it's not very easy to use the data, and I don't think that only affects you, it affects many others. But that kind of governance layer needs to work differently. The whole kind of technical and governance need to form a more cohesive kind of socio-technical infrastructure, right? That's something we can work on together, I'm sure. Right, there's a couple of hands. We've run out of time, but unless Lucy says otherwise, I don't think we're going to need the 15 minutes for the chairs at the end. So I'm happy to give us still another 5 minutes. I see 2 hands. Rachel.
Yes, hello, Rachel Sippy, and I am great presentation. Thank you for that. I'm very interested in the AI mapping that you tried as far as use as concept mapping. And, OHDSI does already have an auto mapper that works kind of, so Usagi. And I guess, how did you find that this the process that you implemented compared to the quality of the mapping that you get out of a tool like Usagi?
Thanks for the question. We have done some evaluation on a couple of tools. I have to admit, when we started the work on the concept mapping automation, we weren't necessarily aware of all of them. I've recently become aware of Hecate, which we haven't seen when we were actually implementing this. So we haven't included Usagi, unfortunately, in our evaluation, so I don't have a good answer to that. But we know that we want to do more principled evaluation of this sort of thing. I would say that we found that the output was good enough to use for most of the output seemed to be correct, and also because it has the semantic similarity in the output as well, we can essentially sort it by the ones that it's not confident about. So we were able to target which ones need more manual validation. So sorry, I can't answer the evaluation question directly, but we found it seemed to work. So that's one data point.
It's also a bit of a moving target. If you just get the AI people to stop developing new things, then we could.
Thank you.
Antonella.
Yeah, I'm interested in the identifiable data you mentioned. So in some of the slides, I saw the NHS number. So I would like to understand first why you need it. Secondly, how you use it.
Sure. I think one thing to mention is the medallion architecture that was mentioned at the start. When the research extracts are produced for a specific approved project, the NHS number and anything that's directly identifiable is removed and replaced by a study-specific ID. But before that, within the data warehouse itself, where NHS numbers are used, and the reason to use it is to link across the different data sets. So linking the reporting data sets from different trusts and for instance, the EPR data, you might have a patient that's in multiple trusts data sets. So that's why we're using it for the linkage.
Thank you, Joe.
Okay. So you use the NHS number, let's say, alone as a binary information for linkage, correct?
Yes.
Yep.
Yeah. Okay, because the NHS England till recently had a sort of 8-step algorithm involving NHS number, but the address, the day of birth, and other information to make the linkage secure. So, but anyway, you use the NHS number.
Yeah, we don't think that's a terribly good idea. We think that obviously NHS, if it's for care, you have slightly different processes and considerations. We don't subscribe to the NHS England notions of data linkage, really. I mean, the NHS number is used reliably within our organisations. You might, in some circumstances, you'll have two numbers allocated to the same individual. And in some cases, you will get, errors. But, our job is to catch them, or if we're unsure, just don't use the data. We then can run statistical checks to make sure, well, you know, are you sure this is performing well? But the idea of doing a stochastic, potentially unstable linkage based on partial address information, the spelling of names, which is very inconsistent. The NHS number, even that is a string in a Cerner system, but we can go through some validation. So that's the key for linkage. And that's the way we should proceed for this sort of stuff. I mean, we do take MRN numbers into account as well, but not in the same way. The NHS numbers, the primary one, it's how we link to the national demographic stuff. It's how do we deal with the spine. It's how we deal with the opt-out. So it's, you know, and the spine will give you you can get confirmed latest additional data on them, but it's not, it doesn't help you with the initial reliability. So and because we're dealing with contemporary data most of the time, and it's not such a, it's reliably used. So we're not too worried about that.
Okay.
And I just saw a comment in the chat about the governance, and yeah, it doesn't fully answer the question, but something to say as well. Sometimes people ask for data on, if people want data for people who don't have NHS numbers, we haven't put high priority on handling that because we don't have any governance to give that data out. Because the national data opt-out requires the NHS number to work.
Yeah, but it's also S flagging. So we have, say, I don't think it's disclosive to say that we have 48 patients in OUH who have S flags on their records nationally. But it's, yeah, we just don't include those, and we you know, they don't make their way through the SDE.
And
sorry, I think we're running out of time, and we still have.
Okay, never mind.
I want to take at least Nick's question before we move on to the next presenter. Nick.
Hi, thanks. Really interesting talk. Nick Kennedy, I'm based in Exeter, part of the South West SDE team from a secondary care data perspective. You talked about having free text in your, I think all the way through to your gold A layer. Are you using any mapping from free text at the moment to OMOP, or are you just using structured data in the maps you've currently built?
Just structured data currently.
Just structured data at the moment.
Is there a
free text is what we will be doing, but it's not what we're doing for OMOP at the moment.
Yeah.
Most of
is that in the pipeline? Because obviously that's something that, you know, we those of us who work with secondary care data are aware of how much hidden useful data there is in the free text. So the fact you've got free text at all is definitely a really good asset, and it's obviously a harder thing to hand over to researchers unprocessed. So yeah, it'd be good to look at ways of sharing whatever you come up with for that in future.
We'd love to share.
Right.
Let me just say, if we only had all the SDs mapped to OMOP with only the structured data, we would be in a very different place. So let me say my plea that let's start by the structured data first, and then see when we can do the unstructured. All right, let me introduce the next speaker. Thank you so much, Jim and Joe. We're a bit over time, but as I said, I hope we don't need the 15 minutes at the end. I'm going to introduce Xin Tong Li, who is a postdoctoral researcher here at Oxford, and she's going to be showing us what can you do when you have access to structured data in OMOP from different countries. Xin Tong, when you're ready, please share your screen and illustrate this.
Sure, thank you, Danny. Hope you can see my screen now.
Yes, very well.
Okay, perfect. I'll just get started. Yeah, so thanks for these two talks, and mine's one is more on the implementation set, as Danny explained, where we conducted a study looking at the use of the ADHD medications in Europe. So a little bit about me. I'm a postdoc researcher here in the Oxford in the groups led by Danny, and he also work as a principal investigators in Darwin EUs with a background in pharmacotherapy and also real-world data. And I've been working with the mapped OMOP SIG data since 2020. So this is my disclaimer, but basically everything I present today is not EMA's review, but my own opinion. And short outlines, I'll get started. So this study is a study from the Darwin EU network, which I guess you have heard about before. Is a federated network of data exploration service that is sponsored by the European medical agencies, with a network of real-world data that been mapped OMOP across multiple European countries. So basically within Darwin EU, there are 4 types of study we conducted regularly. That's starting from off-the-shelf studies, complex, routinely repeated, and also very complex studies. So the off-the-shelf studies mostly contains of studies that looking at patient-level characterizations, drug utilizations, and also population-level descriptive analysis, such as incidence and prevalence. And the study I'm going to talk about today is a off-the-shelf studies, and has been registered on the EMA's WWD catalogs. So a little bit background. As I hope everyone heard this condition before, it's a neurodevelopment conditions with the prevalence around 3 to 5% across the world. Traditionally was considered as a childhood conditions, but in the recent decades, it's been more recognized in the elder populations. And we see the increase in the diagnosis across the whole world in the past few decades. And corresponding to that, there are also a lot of literatures on the use of medications. And basically, we also see a general increase in all the medications that's used for treating ADHD. So that brings to the aim of the study, which we aim to estimate the trends for ADHD medications among both children as well as adults in Europe. So a bit on the methods, we're using the UK CPRD data, CPRD Gold to be more specific, which is the primary care data that's in the UK. It is a populational level observational studies where we're looking at the 5 medications that's currently been approved for treatment of ADHD, including 3 stimulants, the methylphenidates, dextroamphetamines, dexamphetamines, as well as 2 non-stimulants, which including atomoxetine and also guanfacine. So for the study, we included people who are aged 3 years or older, and also requires them to be in the database for at least 365 days. And we define 4 age groups based on the clinical relevance, so that's including children, adolescents, young adults, as well as adults, which are those aged than 25 years old plus. So in this specific study, we characterize the people who are the instant user of medications, and then we're looking at the yearly prevalence, also incidence of the medication use, as well as we calculate the proportion of patient covered, which is a similar concept as Kaplan-Meier, that you can look at the persistence of medications, but it's not only just looking at the discontinuation, but also allowing patient to join back to the cohort after they discontinue from the medication again. So in the end, it's a persistent muscle estimates. So we conduct the study in the CPRD data from 2010 and to 2023, which is the available data by the time we conducted it. So in the whole CPRD Gold data set, we identified like just over 31K new users of any of the 5 mentioned medications. And we see the average age for the initiators was about 15 years old. And also we showed distributions across all the 4 defined age groups. So mostly is in the youngest groups, followed by the second younger groups. And among all those initiators, the majority males, 70% are males among all the users. So apart from looking at any of the 5 medications, we were also able to break it down to the initiator of each of the 5 included medications. Among of them, the one on the the right-hand side column, which is mesfentanate, which is currently the first-line treatment. We find most of the users there. And we could see the average risk different by medications, but similarly for all those individual ones, they are predominantly prescribed to male. So this is the incidence, the characteristics. And then we're looking at the prevalence or yearly period prevalence of use for these medications. We stratify them by age and sex, so color differently here, and presenting by the age groups. So on the far left column, we could see that for both male and female during the whole study period, but included the incidence rates, the prevalence has increased for both the genders. And then if we're looking at all these individual 4 age groups, we could see a similar story there, that the incidence rate, the prevalence of the medication use has increased for both genders, especially for the 12 to 17 and 18 to 24 age group. We see the increase is even sharper after the 2020 of the pandemic. So, and also for among the 18 to 24 group, we could see the increased trend after the pandemics even sharper for females, which is colored in blue, than males, which is colored in yellow. And apart from the prevalence, we're also looking at the incident users, which are defined by people who don't have any of the medications in the year before. So again, we see a very similar patterns in the both genders across age groups. And interestingly, in the 2 adult groups, so the 18 to 24 and 25 plus, we see that at the beginning of the study period, the incidence rates were higher among males, but in the last 2 data points, we see that females actually have higher incidence rates than males. So we are also able to plot it a different way for the male to female ratios of the incidence rates. So on the horizontal line, we have years, and each of the rows represent the different age groups. So the color represents the ratio between male to females, and the more blue purplish means the ratio are similar. So basically, it's a very similar story to the previous line, that on the 25 plus years old group on the top row, we see by the end of the period, more females initiate medications than males. And lastly, looking at the proportion of patient covered. So if you look at the first column is for everyone that we included in the cohort of initiators, we see the proportion of patient coverage is not very high across, it's like decreasing over times by 365 days or years. There's only about like 30% of people who are still on the medications. And we're also able to plot this aptly for males and females across all the defined age groups. So that's the first set of results. And remember, the aim I said at the very beginning was we want to estimate the use across Europe. So apart from the result from the CPRD data, we're actually using the existing network with Darwin's. We're able to conduct the same analysis in another 4 different databases. That's including the data source from Germany, Belgium, the Netherlands, and also in Spain. So similar table as before, we're now able to see the number of identified new users across all those 5 databases, and see the numbers vary a bit, different data sources, and also the age distribution are different as well. So apart from age and sex, we're also looking at who are the people who actually receive this treatment, or what are their characteristics. So here are the listed selected comorbidities and also medication use in the time prior to the ADHD medication. So on the top panel is stratified by the age groups, and the lower is by male versus female. So roughly, we could tell that a lot of those medications has been, such as antidepressants or other psychoactylics, has been used among people with ADHD medications, especially in the older age groups. And also, it's more frequently used among females than males. So this result is quite important because a lot of those conditions are also medication use are used as exclusion criteria for clinical trials on the ADHD medications. So this is a story that telling us that the real world patient that we see using these medications are not exactly the same as what we have for the clinical trials. And similarly, we're able to plot this prevalence for different data sources. So you see there are huge variance between the countries, and they're more used in Germany, in the Netherlands data. But for all of the data sources, we see an increase in use as a similar story. And if we look at the prevalence for age and groups and by age group and sex in the databases, we see that the increased trend for the young adults and older adults is very consistent across all the databases, that there's a huge increase in use among females that older than 18 years old. Whilst for the younger groups, the trends might differ by the countries. And also, this is just the incidence rates with a similar story. Not going to go too much detail into this one. And for the proportion of patient coverage, we also estimated in all the data sources. And for example, on the first row at 180 days, the PPC difference across databases, where we see a higher persistence in the Spanish data and lower for the Germany and the Netherlands data. And by the end of 5 years after treatment initiations, the persistence is generally very low for all the data sources. And apart from these results I showed from the 5 studies, we also conducted a second analysis on the same topic as a routine repeated study as in Darwin EU, where we were able to add in another 4 more databases from Denmark, Germany, Spain, and also Sweden and Norway. So here I was able to combine these results of all the 10 databases together, looking at the prevalence of these medications, and it shows a increasing trend consistently. So this is just a quick summary that in this study, we are able to run the analysis across multiple multiple countries, where we observed increased incident prevalence and the uses, especially among adults. And we see the decreased difference between male and female incidence rates. And the population, the real world user, are not exactly the same as clinical trials. And not but least, this analysis is only possible for all the databases is because they were being mapped in the OMOP Common Data Model, and we use standardized analytics. So the first bit of result I presented actually been published recently, and then we also it also received a quite wide media coverage, which also reflecting the attentions from the public on these topics. And lastly, the analysis is not possible with these packages that's been developed here in Team Oxford, especially the cohort characteristics, incident prevalence, and also drug utilizations, which are open source software to conduct this description analysis. So I think that closed my talk, and happy to take many questions. Thank you.
Thank you, Xintong. I love that you elegantly say that you just replicated the analysis across a few countries. Just I think that was something that people do very often. All right, I think we're open for questions. You said many questions, maybe not many, but let's hope you can take a couple of lists.
Sure.
Dan, I think I saw your hand up, but then it went down again. Dan Bedman.
Sorry, Donny, that was meant to be a clap rather than a hand up. Sorry.
Okay. Any questions, anyone? Shinto, in the meantime, can you tell us how long did it take to complete this study from protocol approval by the requester, which was the European Medicines Agency, until report?
3 months.
3 months. Okay.
Yeah.
Dan, is that another applause or is that a proper hand up now?
No. This was a question. I mean, the increase in use of medications in females from the age 18, well, teenagers and above, is very striking in a number of databases. I was just wondering what the thinking on this is, and whether, because it's always been considered to be much more common in males, is that because there's something about very young boys that makes it get picked up earlier, and the perception is shifting away from it being a sort of male preponderance?
Yeah, I think the reason behind this, the observed increase, is very complex. So first of all, is like there, since 2013, there's a change in the clinical guidelines where broaden the definition for diagnosis, especially among older adults or like people older than 18. And also in the recent years, there are increasingly attention or recognition of those conditions in females, which might behave as different symptoms. So rather than being hyperactive, females tend to be more on the side of inattentives. And also there's part written from, like, we see a lot of information related on social media. So that, I would say, is a combination of all these factors that's leading to those increases. Yeah.
Yeah, and I think the mass media actually realized that trend because this paper made it quite a lot into newspapers, right? Any other questions? Otherwise, thank you so much, everyone. It's quite an interesting day today. I don't know, Lucy, if you want to say anything to close the meeting, but it's been great to chair today and to hear so many interesting presentations and questions.
Thank you, Danny, and yes, thank you. Echoing my thanks as well. It's been a really interesting and informative set of presentations. So thank you all very much, and hopefully see some of you when we get into Nottingham in September. Is there any other business? I think I am meant to close any other business at all. Anybody wants to raise anything in the last couple of minutes? In which case, huge thanks, a bit of a round of applause to our presenters and to Danny for chairing so brilliantly. So thanks all very much. Have a good rest of the day, everybody. Take care. Bye-bye.
Thank you, everyone.